Still people coming. Okay, let's get started. Hello, everyone. Welcome to the last session for IETF 117. After this session, you all are good to go back home. We are You're here for Stub Networking Auto Configuration Working Group meeting. Next slide, please. This is our last session, but let's still take our note well seriously. IETF spends a lot of effort and energy in putting all the processes and procedures in place. Make sure you're aware of them. And if you have any doubts, please ask us, come to us, and our area directors here, just reach out to him as well. Next slide. So I learned one thing that when you're in the room, please use in-room tool. And if you're remote, use remote tool. And these are the icons for those, how to access those links. Next slide. I am looking for someone to take notes. We need a scribe for the meeting today. Volunteers, please. Yeah. So
I think Tim said yes.
Tim said yes. We don't need anything descriptive, just some of the points that can be taken back to the list and all. I mean, everything is recorded. We just need some highlights. Yay, Bob has volunteered. Thank you so much, Bob. Next slide. Okay, so let me start with the bad news and good news. As you can see, this is a younger version of Mark. And Mark is pretty busy. He has started looking into some different technology area, and he could not spend as much time. This group was just taking a lot of time. And so Darren's stepping in, and this is a good time for Eric. You want to say something?
No, I simply want to. Mark Blanchet is in a flight back home because the snack time has been changed at the last minute. So, bed planning regarding the flight. I simply, as an AD, want to thank on the minute. So, Bob, if you can put in the minute that Eric is thanking Mark for getting the chair and thanking Darren to come back. So,
Yeah,
so please
like
be kind with Darren because I think this is your first working group sharing, right?
Very first.
Okay.
yeah, likewise for me. I want to thank Mark for helping me, and whatever I learned, I'm gonna pass it on to you, Darren. I do want to give, we have very thin agenda, so I do want to give a minute or two to Darren to talk about himself.
Okay. Yeah, I'm Darren Dukes. I I've been working in networking for a long time. I guess 30 years. Um, in different, starting out in modems and in NIC cards, and then crypto devices and IPsec and IKE. That was my first experiences in the IETF back in the early 2000s, late 90s. Um, and most recently in, well, then there's been a lot of IPv6 work along the way, but IETF related, some segment routing work several years ago. Now that's gone by fast. Bob and I spent a lot of time together. Got to know each other very well. Yeah, I'm happy to help out and happy to volunteer my time and energy and with this great group of people and see what we can do with SNAC. I'm looking forward to it.
Thank you, Darren, again. We have just one document, and Ted's going to talk about it. This is simple O1, and as of 6 to 4 a.m. this morning, we have version O2. So I spoke to Ted offline. He's been just too busy to upload the document. And since this is the only document, we made an exception to kind of bypass the procedure and not have document before the deadline and still talk about it. But hopefully we will see some good progress going forward. Next slide. We have gone through the administrative work, and Ted is up here to talk about the next two topics. First, we will discuss the updates with the document, and then you want to run through the use cases. I think they will be kind of combined and overlapping, so please feel free to ask questions in between. Ted, the floor is yours. Let's push this.
So,
Yeah.
you hear me?
Yeah.
Oh, you are? Okay, I can't hear. Maybe I'm just deaf. So, let's see. First, I'm going to talk about the stub networks document. I will say the document, the update that I published this morning.
No.
It is. See, I told you it wasn't working.
Maybe there's a switch on it.
Oh, yeah.
On off switch. Check this out. Power. All right. So the update that I published this morning is largely editorial. Darren had some observations, and there were some other comments that had been made previously. So really what I'm going to be talking about is not, you don't need to have read the -02 version of the document to follow this presentation. I kind of went through the document in detail today to figure out exactly what we need to do to get to working group last call, because that's what we all want, right? And so this is going to be a pretty detailed look at the document. I realize probably not everybody in here has read the document. That's okay. I'm not going to shame you for that. So if something that I'm saying doesn't make sense and you have questions, please just come up to the mic and ask the questions. Don't be shy. So let's go to the next slide. So situation with the document, as I said, the update's pretty editorial. There were a few sort of technical issues, but no substantial changes. And so we've pretty much been in a holding pattern since the -0 version was published. And so I've just been going, I just went over it. I read the introduction today and noticed that there are a few issues with it. One of the issues is that when we talked about what to put in the simple document, there was some controversy over whether we wanted to have support for PD in the simple document or whether that was going to go in the second document. We ultimately decided to put it in the simple document, but the introduction still reads as if we hadn't put it in the simple document. So, I've actually done a post-02 editorial change to the introduction to fix that. And so that's about it for the introduction. Next slide. So I'm just going to go through the document by section. This is, like I said, it's a bit detailed. Hopefully this is of interest to somebody here. So the first section is on managing addressability on the AIL, the adjacent infrastructure link. And managing addressability means making sure that there's an IP address for hosts to use to communicate with devices on the stub network. So this section is pretty complete. Except that I think it's a little bit like the organization is a little weird. We have a section that's explicitly talking about the usable prefix, which is, if there's a prefix on infrastructure already, we don't have to publish one. What does a prefix like that look like? And so later on in the document, we talk about like how to sort of the details of how to reason about the usable prefix. And that isn't in the usable prefix section, which seems a little bit dumb. So and this is particularly for the case where you might have competing stub routers providing a usable prefix on the link and what to do there. So there are a few sort of organizational changes. So this is just kind of like a to-do list. There's nothing terribly exciting or controversial here. Next slide. And then managing addressability on the stub network. basically, when I wrote that section, I had just written the previous section, which gave detailed instructions on how to, including a state machine, on how to manage the AIL prefix. And so I basically just referred back to that section and didn't say much more. But it turns out that probably wasn't enough. So this section needs a little work. The handling, like we don't anticipate there being a prefix on the stub network that was published by infrastructure. The whole point is that the stub router is essentially the infrastructure. So that bit needs to be, we need to talk about that difference. And we also maybe need to talk a little bit about how things happen with respect to partitioning, although I think we're fairly solid on that. So again, there's no major changes required here, but I think this document needs to be a little more, this section needs to be a little more prescriptive, and so that can use a rewrite. And again, these notes I'm actually thinking of as a to-do list for the document editors, which is me and Jonathan. So next slide. So then there's a pair of sections about maintaining the AIL prefix and generating a ULA prefix to provide reachability. These sections are kind of related to the previous sections that I just discussed. And there's some interdependence. And also we had some theories about how this was going to work in the sort of early days of Thread that we wound up deciding didn't work that well. In particular, if you have multiple stub routers connected to the same infrastructure that are providing transit to the same stub network, if the PIO that's advertised by a stub router on infrastructure changes over time, this can create reachability problems. And it turns out that for Thread, Thread has an identifier that's associated with the network that's a nice big random number. And so we actually just use that to produce a ULA prefix. And that means that every router that's providing transit to that Thread network is always going to advertise that PIO, which means that the PIO is going to be changing all the time, which means that you don't have these reachability problems I was just describing. For the Wi-Fi stub router use case, I'm not sure how to think about that. The Wi-Fi stub router use case is a use case where we don't actually have a customer for it. We're keeping it in mind just so that we don't sort of constrain what we're doing with stub networks to only the Thread use case. Because the whole goal of doing the stub networks work in IETF is to come up with a spec that's generalizable, that can be used for other use cases. And by thinking about Wi-Fi, we benefit from it gives us an opportunity to sort of contrast and compare. The one thing I think about though with Wi-Fi is not a mesh network, at least typically. And so a self-organizing Wi-Fi mesh network is not really what the problem we're trying to solve here. And so I think that for Wi-Fi networks, chances are you're only actually going to have one stub router connecting you to the Wi-Fi network. And if that's the case, then this problem essentially goes away. So I think it's worth talking about both of the things that I just described here in the document. But I don't think we have a huge problem we have to solve here. I think we just need to talk about it in the document. So, so that's kind of what I would suggest to do here. And I'm curious if anybody has any sort of, if anybody, first of all, disagrees with my position about the Wi-Fi use case, because I think it would be interesting. Julius disagrees. Excellent. Let's hear it.
No, I'm not disagreeing for once. I'm just a little bit concerned about your comment about using the Wi-Fi SSID. Yeah. So I'm not saying anything about Thread because I don't know Thread, but in the case of Wi-Fi, you're mixing the layers here, which might cause issues like, for example, when the Wi-Fi access point is just a bridge, and the router is actually an Ethernet router that's connected to the Wi-Fi access point. So, this kind of taking the SSID and putting it at the network layer is, I don't have any, concrete example, but it's something that makes me nervous.
Yeah, I agree. I mean, I'm not that thrilled with the SSID idea either. It was just an idea that we came up with the other day when we were talking about this that seemed better than nothing. But what I was saying about like the sort of single egress scenario, I think actually kind of addresses this, because now we can just generate a ULA using a random number generator, store it in stable storage, and never change it. It's not a problem.
Absolutely. I much prefer that. I feel much more comfortable with that.
Yeah, same. Cool. Okay. Probably talked about this enough. Next slide. So prefix delegation. We don't currently have a state machine in this section. I think we need one. But I've personally implemented a state machine, and I suspect there's one in OpenThread as well. So I'm pretty sure we can come up with something. So I don't see this as an impediment to quickly making progress. The other issue is we don't actually talk about keeping the prefix, the OSNR prefix. That's the prefix that's advertised on the stub network stable. We talk about keeping the AIL prefix stable, but that's a slightly separate thing. Tim, did you want me to finish, or you want to jump in now? Okay. Either way is fine. No problem. But anyway, so it would be nice if we could come up with a way to keep the OSNR prefix stable. In the thread implementation, we currently don't. If the router that's publishing the OSNR prefix goes away, we just renumber. Tough luck. And the problem here, and this prefix delegation doesn't solve this problem, because we still need a stable identifier to present to the DHCP server, so that we get a consistent prefix back from it, whichever router asks the question. We could use the XPAN ID for that. So maybe we have an option there, but we can't. We're definitely using the XPAN ID a lot at this point, so we need to be a little careful about that. But yeah, so this is something I don't actually think that we need to solve this problem for the simple document, but I think we should think about whether there's maybe a follow-on document that could talk about this, or whether we actually do consider this important enough to hold the simple document until we come up with a solution.
Clarifying question: do you mean IAID or DUID? IAID, mine.
You're right.
Yeah.
Well, so the IAID is the DUID plus the interface index, right? Am I wrong? I don't remember anymore. I'm pretty sure I wrote that section of the original RFC, but that was a really long time ago. So anyway, what I mean by that is the full identifier that's being passed to the DHCP server to say, to give so the identity. So I think the term is identity association, actually. So the DUID plus the IAID produces the identity association, and it's the identity association, the IA, that we want to have stable over time, so that and across different stub routers. So if we can figure out a way to do that, I think that would be cool. Anyway, Tim, you've been waiting a while.
Tim Chan. Sorry, Ted, where is that prefix being used when you're talking about that?
So let me just review for a moment. There are basically two prefixes that we're talking about. There's the prefix on the AIL, the adjacent infrastructure link. So that's your Wi-Fi network that your stub router is connecting to, or your Ethernet, or whatever that your stub router is connecting to, the northbound interface. And then the stub network itself needs a prefix as well. And OSNR stands for off stub net routable prefix. So that's the prefix on the stub network. Yeah, the term that we use in the thread spec is the the OMR prefix, the off mesh routable prefix. But we had to add an extra letter here to make it more complicated.
Yeah, so Tim Chan, I haven't really thought it through at all. Maybe a stupid idea, but is there something in terms of getting the stable ULA prefix? I'm not sure wholly about the rules for generating ULAs, to do something. Sorry?
No. Well, for DHCP, it's global connectivity, yeah.
So you're talking about the ULA 3 or 4 slides ago, and I was having trouble with my buttons. So.
Yeah.
So there was a question at the bottom about, can we do better in terms of getting a stable ULA over reboots?
Yeah, so I kind of mashed that in here because I think it's the same problem. Like, is there a way to agree on a thing that we can use to generate the OSNR prefix? So that we deterministically always have the same OSNR prefix. This is slightly complicated by the fact that with the infrastructure link, we don't expect that to ever partition, but the stub network link, and certainly in the thread use case, at least historically, could partition. And when it partitions, you now need different OSNR prefixes on each partition. So that creates a problem when we're trying to make the OSNR prefix stable, because now you need multiple OSNR prefixes. You need some way to deterministically identify each partition, which we don't have.
Leave it up to the type of network that's trying to associate, and like leave it up to them to decide what it is. For a Wi-Fi network, the obvious candidate is the BSSID of the thing that's connecting to you, right?
Right.
And for thread, you have one, right? So you could say, well, it needs to be like, you need a pointer, you need a blob and a length, and that's the ID, and then you put it in the IAD. I don't know if there's like any length limits in the IAD. Maybe
No, not really.
But then, yeah, then maybe you can say, well, that's up to the technology that's interoperating with you, and it's up to them to decide what it is.
But is it that you're, sorry, Tim Channing, is it that you're trying to do something like 7217, where you want a stable ULA prefix per infrastructure prefix that you're attaching to? Is it that type of thing?
No, it's there isn't a one-to-one map like that. It's just we need a prefix for any broadcast domain that's on the stub network side. That needs to have a prefix.
Right.
Because if we have, let's say that the sub network is partitioned, which can happen, at least at this point, it might not happen so much with thread, but we still need to account for the possibility of it happening. If it happens with thread, now we have two sets of border routers that both have the same prefix, but the prefix is being advertised as on link on two separate, essentially on two separate subnets. And so there's no, the routing becomes ambiguous.
Ambiguous is an understatement. I would say you're doomed.
In anything that's supposed to operate automatically, ambiguity means you're doomed. Yes.
For those not in the room, that was Lorenzo saying we're doomed.
Yeah.
Thank you.
Yeah. Thanks. So anyway, I think this is a slightly open, unsolved problem, and I don't know quite what to do about it. But you know, I'm not sure that we need to solve this to get to working group last call on this document. I just think it's something we need to think about and maybe come up with a solution to, that we could just, you know, if we figure out a solution before we're done with this, great. And if we don't, then we can just have that be a potential additional action item. So next slide. Okay, managing reachability from infrastructure to on the adjacent infrastructure link and on the stub network. So reachability is basically routes, a route from the AIL to the stub network and a route from the stub network to the AIL. And routes are per prefix, so there might be multiple prefixes advertised on the AIL. And we might want to advertise those routes individually on the stub network, just in case we have two different stub routers that are connected to two different infrastructures, but the same stub network, so that we know which router to choose to reach those specific prefixes. Lorenzo.
I guess maybe it's a good go to the end, but I sort of like, I'm very confused about why you don't always just inject a default into the stub pointing at the BR, because where else are you going to go, right? It's a stub network. It only has one way out. Why don't you just advertise default?
That's the problem now. So yeah, maybe it's worth just a moment of review here. The typical deployment scenario for this right now is that your stub router is a speaker or a set-top box or something else, and you might have 10 of those in your house. And we kind of want there to be more than one of them, because you might have one of them on a power strip and you might just turn off the power strip because you don't know that it's acting as a router. You don't even know what a router is, right? Like, you're just you have a house and it's supposed to work. So, so the whole goal of this is to ride over events like that. In order for that to happen, certainly for the thread use case, we definitely want to have multiple egresses. And when you have multiple egresses, you run into the risk that I just described, which is that they could be connected to different links. And when that happens, you want to tell the devices that are on the stub network which router to use. Jonathan.
Yeah, no, Jonathan. So I just want to provide some background. We've had a lot of discussion about this, whether we wanted to support adjacent infrastructure links and multiple adjacent infrastructure links at the same time.
Yep.
And like how we support that, right? So
Yeah.
one answer is just we talked
Yeah.
about default route, right?
Yeah,
Like
right.
if you have a network that is configured of multiple infrastructure links, and like that's really, we could say that's a network configuration issue.
Yep.
Is that something that's prevalent in an actual consumer use case, which is
Right.
the target market for Thread? I think that's the key question here.
Yeah.
Like we want to make sure users aren't really administering their networks.
Yeah. And
Yeah. Sorry.
oops. Yeah, that was Jonathan. FYI, Jonathan White.
Yeah, Lorenzo, I didn't mean that you should only pass a default, but you can pass a default and some more specifics.
Right. So there's, I mean, one thing to say is that what Jonathan said is actually what we decided to do for Thread, which is basically we assume that if you have multiple adjacent infrastructural links, that you're running your network, or that your network has working routing, basically. If you have multiple adjacent infrastructural links and your network doesn't have working routing, then to hell with you. we just can't support that, right? So what you just said is basically right, Lorenzo, that we could just publish a default route, and in fact, that's what we do. I'll talk about that in the second presentation, but just in principle, I can't remember how we got there from here. Oh yeah, I was just talking about advertising more specific routes on the stub network. Yeah, I think certainly for the simple document, it makes a lot of sense to not really try to dig too far into this problem, for the exact reason that Jonathan gave. That it's we assume that the target for SNAC Simple is a home network, and home networks shouldn't be complicated, and if they are, then we really hope that the home user knows what they're doing, because otherwise they're in deep trouble. So, next slide. And then discoverability. The document mentions all of the stuff that we need to do, but it doesn't actually say how to do it in any kind of detail. And also, it's a little vague about things like SRP. So with Thread, we do advertise SRP on the stub network because we don't want to do multicast on the stub network to do service discovery, for reasons that I think we don't really need to talk about here. I think it's pretty obvious. But suppose we have a Wi-Fi setup. Do we want to advertise SRP on the Wi-Fi network? Currently, nobody supports it, but maybe if we specify a way that they could use it, then they would. So we could talk about that, and the SRP document actually says how to advertise it. So all we would really have to say is you should do this. And then another thing is, like, the DNS resolver on a stub network needs to do a bunch of different things. It needs to act as a discovery proxy so that you can discover MDNS services on the infrastructural link. It needs to act as a DNS resolver so that you can discover devices on the internet, and also internal networks for that matter. And it needs to act as an SRP server. And it probably should support DNS push so that you can do DNSSD. One of the features of DNSSD is the ability to do an ongoing browse so that you can see when a new service shows up. So you probably want DNS push. So none of this is at all difficult, but right now the document doesn't actually specify this, and I think it should. So that's the to-do list for this section. Next. Yeah, and then reachability for IPv4. So one of the simplifying assumptions with SNAC is that the stub network is an IPv6 network. It's not an IPv4 network. We're not providing NAT. We're not providing DHCP. If you're connected to the stub network, you're responsible for generating your own address, and you're responsible for listening for RAs and sending a router solicit if you want to see what the current situation is, all of that stuff. So if you want to communicate with stuff in the cloud, there's two ways that can happen. One is through NAT64, and the other is through direct IPv6. So if the device that's in the cloud is an IPv6 device and you have DHCP, then you can communicate with it. If the device that's in the cloud is an IPv4 device, then you need some kind of NAT64. So So there, and this section right now is, there's kind of a nice long problem statement that I think is useful, but I'm not sure that it's that useful for an implementer, because it's basically just justifying the decisions that we made. And I think for an implementer, what you really want to know is, what should I do? So I'm thinking that we might want to sort of change the section around a little bit, maybe put the justification in an appendix, or maybe we leave it the way it is. I don't know. I'm curious if anybody has any opinions about that, if you've read it. Julius.
Leave it. I mean, it's never, I mean, if you're an implementer, having more background is better, and you can always skip the places that don't interest you. So I would say leaving the text is just fine.
Okay.
Jelnikov, I actually have not read the draft, but I might have an opinion.
I said I wasn't going to shame anybody.
What stayed in the room stays in the room, right?
Exactly.
So I'm just looking at the last 2 points.
Mhm.
I think if you can get rid of DNS 6.4, it would be awesome, right? So maybe requiring Pref 6.4, kind of relying on it, would be a great choice.
Yeah.
Right, because I think like there are a lot of implementations actually around. I would say major large router vendors support this now. As far as I know, there are open source implementations.
Right.
So I think we kind of getting ready to say like Pref 6.4 should be like widely available like quite soon.
So the question that I have is actually, and this is a question that you might be able to answer, Jen, is how prevalent is this in implementations? Like if we're only publishing Pref 64 and we're not providing DNS 64, is everybody going to be able to succeed?
Well, I think it should be our end goal, right? So I'm basically trying to migrate my network to have at least like in some segments, getting rid of DNS 6.4, right? Incrementally. I'm not sure when I will be able to succeed.
Right.
But I think it's also, because I guess it depends of how unified devices are, right?
Yep.
But I guess, it might have segments when I will need to keep DNS 6.4 for longer. But I do see the light at the end of the tunnel for like standard kind devices.
So like if we care mostly about iPhones and Android and stuff like that, do they support it now?
Oh yeah, I'm exactly testing. Yeah, I spent last 2 hours playing with like my laptop on the network, which is V6 only without DNS 6.4. With just Pref 6.4, and it works just perfect.
Great.
MacBook Pro. Thank you very much.
So that wasn't meant to be a sales pitch. I was just curious which OS you were testing. I was just going to add a very quick comment because Ted mentions here sort of obliquely. Fred made the opposite choice. I want to give some background because I think not everybody in the room knows. If you do, I apologize and I'll shut up. We're also not fans of DNS 6.4 because Thread was a greenfield development, right? When we got involved, practically speaking, there was not a large deployed base of Thread devices. So we were able to say, if you're a vendor making a device with a Thread radio with an IP networking stack, then you will do local synthesis. Those are the rules of the game.
Yep.
Put that code in OpenThread. Pretty much everybody uses OpenThread these days. Problem solved. The broader applicability of SNAC at the IETF is not just Thread stub networks, but it's other kinds of stub networks like Ethernet that might have legacy hosts. Yep. So that's why the calculus here is different, because the target of which devices we're supporting is different.
Yeah. Yeah. Although, to Jen's point, if we're 90% of the way there, stub networks, the stub network Wi-Fi use case is, the only actual practical use case that I can think of for this is your home router should be able to be a stub network, so that if the end user plugs one home router into the back of another home router, everything works and you can print and like discover your light switches and stuff, which currently isn't the case. So, with an existing home router, that doesn't work. So we aren't really trying to solve that problem here, but nevertheless, it would be nice if that succeeded. And so if that largely works because hosts largely support it, then great. But anyway, I'll shut up.
Michael?
I can't see it.
Hello. So what we're talking about here initially is, well, one thing, whoever makes this gateway device will have to implement this for V4 because they're going to connect to a V4 only network at some point in time. Do they have an opinion on this, that they need to implement that?
So I mean, we're kind of imagining a market that doesn't exist.
Okay.
There isn't anybody banging down our doors to solve this problem. I just think that it's, you know, if we're going to specify this, we should specify it in such a way that if somebody did decide to implement it, it would do the right thing.
Right. So my opinion is that relying on an external DNS64, that shouldn't be mandatory for this function to work, that exists, because in most cases that it will be a dual stack network if it's like a home network or something, and there will most likely not be a DNS64 function upstream. That would be my guess. So,
right. Well, but the stub network could do DNS64.
Yeah, it could do it itself, yes.
Yeah.
But I'm saying I don't know if it would require, if this says that there should be an external DNS64 for this to work. I don't think.
No, we're not requiring that.
Okay,
that's not what we're saying.
David Lamperter, to be a little bit more pessimistic on the previous question on how widespread implementations of this are, as soon as you look at anything Linux-based, it's very much distribution/application question. Like if you use some OpenWRT box, then hopefully they did the right thing. But there are so many implementers, and it's going to be total hit and miss. But at the same time, I also think the real question here is, what do you do if your thermostat did the right thing and does IPv6, and the cloud for the thermostat does the right thing and does IPv6, but your ISP is IPv4 only?
Right.
And that is the real hard question, I think.
Yeah.
Because we can tell people building those products that they really should be using IPv6 now, but that doesn't help fix the network.
Yeah. Yeah, I mean, practically speaking, what we expect to have happen in that case is that the provider is going to say, well, you know, we still have to be able to receive IPv4 packets because not everybody does IPv6. And so then NAT64 solves the problem for that case. But yeah, I agree that it would be nice if we could not have that be the case.
And Jelinko again, I just realized that I actually think that currently the way I would like to deploy what I call V6 mostly networks, it's actually saying we do not care about DNS64. If you do not support Pref64, do not turn option 108, right? And just be dual stack.
Yeah.
And if you can be V6 only, use Pref64, option 108, be V6 only. In this case, it's possible to basically get rid of DNS64 because devices which do not know about Pref64 can be dual stack.
Yeah.
Right. So I think we kind of would be nice to cover them. I actually don't know, if it's achievable in the this wild west of devices around, but I start thinking it's probably the best deployment scenario we shall be thinking about.
Yeah. Bear in mind that we don't support IPv4 on the stub network, so there's no dual stack. But you know, I mean, there's a case to be made that like this is a weird use case that's not quite deployed yet. Maybe we don't actually know who the customer is for it, and so maybe we should just be optimistic. And you know what, if somebody who's implementing this needs to implement DNS64 because they have a specific problem they're trying to solve, they can do that, but we don't need to specify that.
Just out of curiosity, let's say that we have some light switch that needs a firmware update. What do you? Let's say we don't do DNS64. What do we expect that light switch to do? Let's say it does it's a V6 only host. Does a Code A lookup? What happens now?
So
would it need to have DNS64 in its stub resolver?
So yeah, the expectation is, and this is true for thread devices. The expectation is the thread device is going to ask for a quad A record. We actually specify in the thread spec that the border router, if it gets a request for a quad A record, and there isn't a quad A record, but there is an A record, it will return the A record in the additional section. So you don't need to do an additional query, which saves a little bit of battery.
In the
but-
additional section,
Yeah,
what did the NS folks say about that?
that's the correct thing to do.
Okay, keep going, keep going.
So basically, it can do the synthesis itself.
The
And
thread node would do the synthesis.
so, yeah, and I mean it's not hard to do
Okay.
DNS64 synthesis. So why do
I mean,
it?
if it's greenfield, sure, yeah.
Yeah, exactly. Stuart, did you want to?
Julius is next.
So I'd like to repeat something that I suggested before, and you treated me really badly when I suggested it. So I mean, you strongly disagreed. And so I'll mention it, but I expect you to disagree. So I still think that in the case in which the stub link supports native IPv4, the stub router should be doing NAT44, and that just solves all the problems. So the main reason for that is that anyone who's going to be building a router already has a NAT44 implementation, and that's the expedient solution to solving the legacy problem with IPv4.
Yeah, I agree that that's the expedient solution, and I even agree that if I were shipping a piece of hardware that was doing Wi-Fi to Wi-Fi like this, that's what I would do. The question is, should we say that in the spec?
Yeah, I have to interrupt. Are you okay with the queue? Will you be able to make progress with your presentation?
I think we're pretty close to the end of this
Okay.
one, and the next one is like a nice to have. So if we don't get to it, it's not the end of the world. It's not like
Yeah,
it's
we want
working
to
report.
cover the meat of
Yeah,
the
I mean we have until 1:30, right?
Mhm.
So yeah, basically it's just a question of whether people want to stay that long. Go ahead.
I remember what I was going to say. A bit of background about why in the thread group we decided not to use DNS64. It's not just a religious objection to DNS64. We had some technical debate about the right way to solve this. And one of the strong arguments is that we would like to see more use of DNSSEC. And DNS64 is incompatible with DNSSEC because DNS64 is synthesizing records, aka forging records, and DNSSEC is designed to prevent forgery. So by saying in the thread world, all clients do synthesis locally, it enables those devices to do end-to-end DNSSEC validation and then do their own synthesis locally, which they trust because they're doing it. DNS64 basically blows up DNSSEC and makes it impossible to ever do that. So that was really, I think, the deciding argument.
Yep.
David Lamparter, I need to disagree with Julius. NAT44 is not going to help here. The definition of a stub network is that it doesn't have traffic transiting it, but it may have more than one exit. And as soon as you have more than one exit, what are you going to do when your IPv4 traffic starts moving between your multiple exits? This just doesn't work.
You're doomed.
Yeah. Well, NAT64 has the same problem, right? I don't object to people implementing IPv4, but we do need a solution for networks that aren't IPv4, and so those definitely need to be specified here. We can say maybe like if you support IPv4, you don't have to do NAT64, but why? I mean, why?
I don't think we get anything out of that. If somebody wants to do that, we're not saying don't. We're just saying this is what you must do.
Yeah, I
right?
mean, is IPv4 even in the charter? I mean, we don't have to support it, right? Like we can say if you want to use IPv4, you can also do NAT44, but we don't have to design for it.
I will relay to the mic that Eric shook his head violently when Julius said, "Let's do NAT44." So sorry, Julius.
He's not in the chat.
Yeah, Jelinkov, yeah, I actually agree. Do we really need to work on the legacy protocol here?
I'm good.
Right?
No.
But it wasn't why I actually came here. I have a question because I just don't know what we're dealing with. Do we expect devices use third-party DNS and not one provided by the network? Because if you do, then like whatever router sends you an array does not really matter. I mean, an RDNSS option. I just don't know if like those IoT devices or something might decide that I want to connect to like particular third-party stuff.
Yeah, I mean, if it's your device, right? You can have it talk to whatever IP destination you want to, and if what you want to do is send a DNS query there, we're not going to necessarily stop you, but we might. I mean, there might be a firewall.
I think this is another reason to have devices do NAT64 synthesis locally. My understanding with services like Google's Quad 8 is if you do a query for Quad A for a host name that doesn't have a Quad A, it will do the synthesis using the default NAT64 prefix. So for many installations, kind of by dumb luck, you get the right behavior as long as you're using the default. So, I mean, that's the answer to your question, but really the deeper point is this is one of the reasons we're not a fan of DNS64.
Yep. Okay, next slide. Okay, and then there's a section in the document that talks about handling partitioning events. When I read the section over, I realized that it was basically reiterating what's said in the section on managing the OSNR prefix. And so I don't think we need both sections to be, basically this section probably needs to acknowledge the problem exists and describe what the problem is, and then point back to the other section to describe how it's solved, because it's just solved. The way it's solved is if you get a partition, then the router that was advertising the prefix that's on one partition is no longer going to be reachable on the other partition. And as soon as reachability detection fails, a router on the other prefix is going to on the other partition is going to publish a prefix, and that's already automatic in the way that we do prefix management for the OSNR prefix. So we don't really need to say anything here. Anyway, so the bottom line is this section gets shorter, and I think that's the last slide, other than next steps. So basically my question at this point, and I don't know that we necessarily want to, we've already had some good discussion here, which I'm going to have to go over in the recording. But I think, you know, if anybody can think of stuff that I didn't talk about here that belongs in the document, please let me know, or let Jonathan know. We're the editors of the document. So if we get feedback of that sort, then we'll adjust the to-do list. And then, you know, I think we have a pretty clear set of things to do. So we should just get those done, and then maybe we should do a last call, and that will be the time at which everybody says, no, wait, you're crazy, we can't do that.
So at least I can say about the last call, there are a lot of to-do items.
Yes.
Let's get to them, have them discussed and review, and we will revisit last call after that.
Yes, yes. Yeah. The thing about last call is sometimes it's hard to get people to review if you don't threaten to publish. So
I do have a question as an individual. How about the security perimeter? How secure your stub router is, and how are we dealing with any kind of attacks that stub router can do to your home network?
So
since any device, any laptop can become a stub router,
yes.
So how do you protect your home network against it?
So if somebody has the you know, has your Wi-Fi password, then they can connect to your Wi-Fi and they can send whatever packets your Wi-Fi is willing to forward. There's this thing called RA guard, which we hope isn't on your home network, because if it is, the stub router will stop working. And RA guard prevents you essentially from advertising foreign routes on the network. Generally speaking, the use case for RA guard is managed networks, because that allows the person who's managing the network to say, oh, this is a network where we shouldn't allow this.
So nothing special or specific needs to be done.
Right. Yeah. I mean, you know, the thing is, if something can get access to your network and it can see all the packets on your network, which may or may not be the case depending on the layer 2, you're already vulnerable to a lot of attacks. And I don't think this creates a particularly new attack surface. It's essentially exploiting an attack surface in a sense. So.
Kawashima, you go next.
Hi, I'm Masanobu from NEC Platforms. I'd like to say thank you for this kind of mighty work. As you already know, I've sent some comments on the list a few days ago.
Yeah, thank you.
The first comment is about usable prefix. The Ted already mentioned about it on the slide, so I'm fine with it. We should probably be clarified more. And I'd like to talk about the second comment. Also, what if we add security consideration section on this draft, as we discussed about a while ago? As you may know, RFC 6092 describes recommended simple security capability for IPv6C routers. So if we refer to this RFC, or just pick some recommendations up for the stub router might be useful. So for the implementer's reference, what do you think about it?
So yeah, this is a topic that's been discussed previously on the list. And so the question is, do we want the stub router to have additional security on top of whatever is present on infrastructure? And
I think I don't need additional work. I just want to refer something protecting from protecting IoT devices. So I just want to refer something the security related document. Just a comment though.
yeah, so I mean, the problem with that is it's a little bit of a boiling the ocean problem, and the work, there's been work done in other working groups to address that problem. For example, if you look at the work that was done in MUD, that's management usage descriptions, I think, that talks about a way for devices to inform their infrastructure as to what sorts of communications should be allowed, both the device should be allowed to be able to do, and that that should be allowed for things to do to the device. And then there's also work being done in other standards bodies around this area. I mean, at one point, I think Apple did something with, I can't remember what the context, what the standards context was, but we did something that was talking about basically isolating IoT devices, just as you described. And basically, the observation that we had when we were considering this problem for Thread is that's actually a network management function that probably needs to be at a layer above the stub router. So in other words, your device, there are some devices on your home network that are going to need to be able to talk. Like if you've got, you know, in the case of HomeKit, for example, you've got a bunch of light switches. I mean, I have a bunch of lights in my house, and I want to be able to control those from my phone. My phone is on the infrastructure network. The lights are on the stub network. If we block inbound access to the stub network, then I can't control my lights. So obviously we can't block that for this use, for that particular use case. Doesn't mean that it's always wrong to have a block of that type there, but this is what I'm getting at, is I think that's a little bit out of scope for this particular document. I realize it's uncomfortable because essentially that leaves us without a security considerations section that is, it's going to be a little unsatisfying in the sector review. But this is essentially a network building block, so I'm not sure what to do about it.
Okay. Okay, go ahead. Go ahead.
Yeah, I simply want to say both, Eric Ving, both as an AD and individual contributor, this discussion we just get now is a fantastic working group meeting. Usually it's a one-way communication. This was really enjoyable and very fruitful. So thank you for all participation here. All working groups should be like this.
So,
okay, so I agree what you said. So I just for the comment, if we refer to some security related document, it's just useful for us. Just a comment.
Yeah.
Thank you. Thank you.
Yeah, I think it would be worth collecting some knowledge about this problem and essentially writing up what would start out as a problem statement and see if there's work to be done there. I don't know if there is or not, but
we need to add any
work to be done somewhere.
We need to do. We don't need to do any additional work. I just want to refer some RFC. Just like that. Thank
Okay,
you.
thank you.
On the question of security, I find it both amusing and encouraging that we are effectively exploiting a security vulnerability to build a protocol. That's awesome, right? I think it's really great. Sort of permissionless innovation and all that.
Yes.
And you know, I think this is great. The one thing I wonder sort of is previous attempts to do that, like for example 6-4, have ended extremely badly. I think in the case of 6-4, it was probably like the working model was incorrect. It was relying on the kindness of strangers and so on and so forth. But like we ended up with these NAT gateways that turned on 2002 with a private IP address, and it was just a disaster.
Yep.
I don't think this will happen here because this is an actual concrete use case, and if you break it, people will complain. So I think it's going to be fine. But we might want to sort of bear in the back of our minds, you know, like what could happen to us if, you know, something like some bad implementation or some you know, some developer who is like a bit naive is like, oh yeah, I coupled it together and it works. If they do this, you know, so more in terms of, you know, resilience, as it
Yeah.
were, right?
Yeah, yeah. I mean, it's you know, one question that might come up is like, you know, maybe nobody just nobody thought to do this before, and now that we have an existing example of somebody doing this, other people are going to look at it and say, oh, I didn't realize I could do that. I wonder how I could exploit this. And then problems might ensue. So yeah, you're right. And I think that's, you know, there is work going on in the IETF to address that, but there isn't work going on in the IETF to address that in the home network case. So that's still an interesting question.
In terms of, I mean, the other thing I wonder is that for networks that do use RA-Guard, like enterprise networks, the PD solution might work.
Right. Yeah, it does, absolutely. That's if we could have assumed that your home gateway already did DHCP v6 PD, we would never have come up with the other alternative, right? Because we wouldn't have needed it. So ultimately, the evolution could be and probably should be that home routers wind up providing prefix delegation, even if all they delegate is a ULA, and I broke Lorenzo. Anyway, I won't belabor the point. So, all right, I think that's the end of this slide.
Next one.
Yeah, next one.
Let's see.
So Kieran asked me to find somebody to do a presentation on what we're doing with Thread, and I actually pinged Jonathan, but I think I pinged him at the wrong time. He didn't get back to me, and so I wound up just saying, ask for it, I'll do it myself. So here we are. But the good news is Jonathan already did a presentation about this, and this is very different than his presentation. So hopefully this will be interesting. I basically just plagiarized my previous presentation to produce this one. So let's go. Okay, so the backstory here is Thread had an 802.15.4 mesh network, which was super cool and really neat, and you couldn't connect it to anything because 802.15.4 and Wi-Fi can't be bridged. There was kind of there was a solution that was sort of in place to do that, but it was not ideal. So Thread is IPv6 only. We can't do the bridging because the data rates are incompatible. We'd wind up swamping the Thread network with bridge data. We don't want that. And because we'd be bridging all of the multicast traffic because that's what bridges do. So basically it would be a bad solution, and also we'd have to do layer 2 header translation, which is never a good idea. So moving right along. Next slide. So the scenario here is we've got a lot of devices on the Thread network. We're going to want to be able to control those devices probably from the infrastructure network. They need to be able to be discovered by devices on the infrastructure network, whether they're light switches or whether they're sensors, whatever. We need to be able to find them. We need to be able to send IP packets to them. Historically, the way that this would be solved would be with a hub. Like, for example, you'd have a Philips Hue hub. Philips Hue uses 802.15.4. So if you had only Philips light bulbs, you could control them using IP to the Philips hub, and then there would be some non-IP thing on the back end. And we wanted to get away from that model because what winds up happening is you've got your Philips Hue hub, and then you've got, you know, the next thing, whatever it is. And I actually can't even remember what the products were in this space, but there were, I remember seeing a picture of somebody who had like 5 or 6 of these hubs in a wiring closet, each one of them just allowing them to control 3 or 4 devices, which is just stupid. So the idea here is generality, and also like the devices need to be able to get firmware updates. And if you aren't running IP, how are you going to connect to the cloud to get your firmware update? Next slide. So this is what motivated us to do what we did. Prior to the stub networks work that we did for Thread, there was this function where we used ND proxy to communicate with devices on Thread. There wasn't a discovery protocol. ND proxy isn't very scalable, and it particularly isn't scalable if you have multiple devices that are doing ND proxy. It just gets a little ugly. So so when we looked at that, we just discarded that as a potential solution for our particular use case, we being Apple in this case. So we decided that we wanted to have an actual router because that eliminates the sort of general problems that ND proxy creates with scaling and multiple routers. And we did it. We put together a stub network implementation in TDOS, and we shipped it in the HomePod Mini in 2020. Sure enough, OpenThread implemented similar functionality, which is great. And so now a lot of vendors have routers that have OpenThread in them. So actually, at this point, you know, I'm bragging about HomePod Mini, but at this point, I think quite a few, possibly a majority, I don't know, of the Thread routers are OpenThread based, not Apple. But
is this what the Apple TV does as well?
Yeah. Okay. Yeah. Yeah. Basically, tvOS runs on HomePods and Apple TVs, and I think that's it. So I should know, but anyway. So that's the history. We've been shipping this for what is it, 2023? So we've been shipping this for 3 years. We've got a lot of experience in the field. Next slide. And it seems like it's working. This got integrated into the Thread specification in Thread 1.3. What we were shipping back in 2020 was Thread 1.2.1, I think. So the Thread 1.3 spec became public recently, which is why I can talk about the details at this point. So it has full stub router support, pretty similar to what we describe in the stub router document. But there are some differences that I'm going to describe. And it's supported on lots of things. It runs on home routers, like Eero has a home router. I think Google has a home router. And I'm sure other people do. I don't know of them off the top of my head. Set-top boxes like the Apple TV, Wi-Fi speakers like the HomePod Mini, and I think the new HomePod has it. I think Google has some kind of touchscreen device. I don't know the details. And then light bulbs. So there's a company, Nanoleaf, that ships a light bulb that has Wi-Fi and Thread and will act as a stub router if necessary. Yeah, it's pretty wacky. I mean, because, you know, if you think about it, they're trying to sell light bulbs, right? Well, what if all you have is light bulbs and you don't have a HomePod Mini? We still want it to work. So pretty cool. Next slide. As I mentioned in the previous presentation, one of the issues we ran into is we wanted to have a stable prefix on AIL if we're providing the prefix. And so we did this thing with the XPAN ID to make that work. That mostly works, but if you have multiple thread network connected to the same link, then we still have to do the election. But hopefully you've got, like, you know, 5 routers on one thread network and 5 routers on the other thread network. And so whichever prefix 1 doesn't go away because somebody's maintaining it. So that's kind of the state of things now. That we introduced that, I think, probably in 2011 or 2012 because we were seeing reachability issues with the previous model. Next slide.
Clarifying question.
Yes.
How, if there were 2 thread networks and they AL prefix has not been decided. How do you run the election between the two? Because they can't talk to each other.
So they advertise RAs. This is actually, thank you for mentioning that, because I meant to talk about this and I didn't in the previous presentation. There is a router advertisement flag option that we've added and that we're using for stub routers that allows us to detect whether a prefix is a stub router prefix or not. And so if we see two prefixes advertised, like I'm advertising one, somebody else is advertising another, and they both have the stub router flag, then we do an election between them. And whoever advertised the prefix that loses the election deprecates their prefix, and we let it die. And so, yeah, I mean,
it sounds great if you have two different stub readers for different technologies that can't talk to each other. But yeah.
Well, so
let's take that offline.
Yeah, I mean,
maybe I'm misunderstanding.
Okay, yeah, you know my email address. So anyway, so moving on to the next section, addressability. So this is providing addresses on the stub network. We don't have our router advertisements. We have this thing called the thread network data, which is managed by something called a leader. And so when a stub router comes onto the network, it looks at the thread network data and sees if there's a prefix advertised, not an OMR prefix, which is the thread equivalent of an OSNR prefix. If there isn't, then it advertises one. We try to be really careful about not advertising too many of these because we can fill up the thread network data, and we've actually run into situations where we fill up the thread network data with OSNR prefixes and everything stops working. So,
just a clarifying question. When you say the network, is this now the Ethernet or Wi-Fi? It's not the thread radio network. So when you say thread network, is that on the thread radio?
When I say thread network, I mean the thread mesh network. So
oh,
yeah,
right.
802.15.4.
And when you say network, you mean like the Ethernet it's connected
No.
to? No, okay.
Thread network is the thread network.
Okay.
This is an 802.15.4
yes,
mesh network.
Yep. And when you say on the network.
When I say on the network, I'm referring to whatever network I previously mentioned. Sorry, I might just be doing a bad job of getting my antecedents right. But the infrastructure network is your home Wi-Fi, your home Ethernet, whatever. So whenever I say infrastructure network, that's what I'm talking about. When I say thread network, I mean the stub network.
And when you just say network, you generally mean thread network.
It's anybody's guess. Yeah. When I say network, you should throw tomatoes.
I'm about to throw tomatoes to you and Jonathan here, by the way. Eric Ving, responsibility for this one. You just took a mention of flag into the array.
Yes.
Mentioning is a stub. Just look at the IANA page for history. There is no such flag.
Right. Yeah.
So please request an early allocation.
Yeah.
You know the process.
Yeah. Yeah. Okay. Thank you for making that point, because the point that I meant to make and forgot to in the previous presentation is we actually need to. We have a directive from the 6-man chairs, both of whom are present in the room, which is we're supposed to figure out what the flag does and write a document that describes it. And once we've agreed on what the document is supposed to say here, we're going to bring it to 6-man, and that's where the document is going to hopefully advance. But you're right, we should ask for an early allocation. Yeah, thank you. Okay. So let's see. Anyway, yeah, so next slide. So this is the problem with having written the slides a couple hours ago. My brain has completely lost what I was talking about. Yeah, we don't actually, there's some stuff in the document about maintaining a stable prefix on the AIL. And because we're using the XPAN ID, we don't really have a problem there. The XPAN ID is already maintained in stable storage on the thread devices, because that's part of the credentials that they use to join the thread network. So we just take advantage of the fact that that's there and stable. But for the stub network, we don't have that advantage. And so every thread border router has its own ULA prefix that it's generated It's a /48. It's generated with a random number generator, the way it's supposed to be. And so whichever one publishes first, generally that's the one that's going to win. If two publish at the same time, we do an election similar to what I talked about for the AIL prefix, and one of them goes away. So this can cause problems because, for example, if a stub router goes away that was publishing the prefix, we publish a new prefix, all of the devices on the network now have to renumber. We now wind up with SRP advertisement updates for every single device on the thread network. It ain't pretty. It'd be nice to come up with a solution for that, but right now we don't have one. So what we're doing right now is just what I described.
So just clarifying questions, since I don't know how this works. So if there are two stub routers, each have their own thread network, and this election happens, is then the thread radio network collapsed into a single mesh, and then one of them just gives up and does nothing anymore? Or?
No, the thread stuff is all happening kind of at layer 2. So the thread network either is one network with two stub routers on it, because remember, it's a mesh. So these stub routers are just elements in the mesh.
Okay.
They're actually part of the mesh.
Right.
So either the network has been joined because it has, a shared network identifier and a shared credential, or it hasn't been joined because they have disjoint credentials. Right. And if they have disjoint credentials, then and so that could either be by design, we actually want two thread networks, or by accident, we form two thread networks, but we'd really rather have one. In the second case, thread needs to take care of that. So that's totally out of scope for this. But in fact, we do have functionality in thread border routers that tries to avoid having two thread networks, just for that reason.
Okay. And generally, these two thread stub routers, if I want to have two separate networks, do they then on the infrastructure network side, like, join up and present on a service discovery point of view? Do they become one?
No, because you decided you wanted separate thread networks. They're just separate.
Okay.
Related question. Let's say I have a thread network with one XPAN ID, and then I move the light bulbs away, or I close the door, or whatever, and they can't see each other anymore, and it partitions. Like, what actually happens? Right? Does that become a different thread network, or
no? The credentials remain the same. However, one thing that I hadn't mentioned previously is that it's actually, at this point with thread 1.3, relatively unlikely that you would wind up with a partition like that, because if they're both connected to the same infrastructure network, we'll just bridge the thread network mesh over Wi-Fi. So the partition event doesn't actually happen in that case, because we do have a way to get packets from between the two partitions.
if each partition has a BR?
Yes. If, on the other hand, there's a partition that doesn't have a BR, well, tough luck.
But then it doesn't matter, right? Because you can't. Yeah.
You can't reach it. Yeah. I mean, the case where we would run into trouble is if we have a partition and one BR is on a different infrastructural link than the other, then we can't heal the partition. Maybe.
You bridge this on the BR. You bridge this in the infrastructure link. They're using the same prefix. How? Because you got these two stubs. They're using the same.
Well, if they're not partitioned, then it's fine.
Right, and you've got the one thread network using 164 and it's partitions into two pieces. How do you use the infrastructure link to bridge? How does the infrastructure link?
That's being bridged at layer. So basically, we have a layer 2 tunnel between the two meshes. So it's not. We're not creating two different subnets that are bridged together. Okay. So
Ted, sorry, Darren Dukes. So when you have two stub routers on two different infrastructure networks and potentially forming just a single mesh, is that right? Did I hear you right?
So yeah, it's certainly possible, because thread is its own transport, right? So it's entirely possible to have a single thread mesh that has egresses to more than one infrastructure link.
Okay.
And in the partition case, if we have routability between the two and discoverability between the two, then actually we can still send the packets over IP routing. So we can heal the partition over a routed IP network as well. But that's not going to be the normal use case in a customer, not like in a home.
Yeah, I'm just thinking apartments, right, with things that are close together.
Well, so they don't join automatically, because they have to have credentials,
okay.
right? So if you got two people in an apartment building that can see each other's thread devices, they can't actually join each other's thread networks unless they share credentials.
Okay, thanks.
David Lamparter, what happens in that exact case when you do share credentials by accident or by social stupidity? Like I have one thread network with two completely different, like two completely different apartments.
Yeah.
And they just happen to use the same credentials because someone didn't understand how this works, and but I have two completely different networks otherwise. Is that?
That could happen in theory. I don't think that would generally happen with existing products. So in a sense, that's being dealt with at the application layer. For example, if you're using, I think if you're using HomeKit, you would need to have, you'd need to both HomeKit homes would have to be joined together, which would involve actually deliberately connecting Apple credentials to each other, which I think would be kind of hard to do. I don't even know how you would do that.
Well, I mean, it might be hard to do in the Apple case. So
yeah,
my home network uses some random, I think, Bosch gateway. I don't think it's as hard to get it wrong there, which, I mean, credit to Apple to make it hard to get wrong.
Yeah.
So I am asking this mostly out of curiosity than consideration and for the actual draft. But
so, I mean, we've in Thread in particular, we've always had this delineation between sort of, we call it application versus Thread is application agnostic, and application is not used in exactly the same way that it's used in the IETF. So things like fair hair and what are some examples? Trying to come up with something, but basically like matter, KNX, matter, KNX. There's that other infrastructure, building infrastructure thing that's very common in Europe. I can't remember. But anyway, the point is that these things are essentially responsible for managing credentials for the devices that are being managed by them. And so our expectation is that whatever sort of application ecosystem you're using will have some way of doing that. And so even if your thread networks merge, I mean, Thread's security model is not exactly super strong, right? So you've got to have something at the application layer anyway. And so that's where we expect that problem, the concern that you have, to be addressed.
Ted, just a time check. You have 10 minutes.
Okay. I think we're pretty close. Yeah. I think we covered all of this. So next slide. Prefix delegation, we do it. It works. We see it happening in the field. So I actually get bug reports occasionally where I have a crash because I made a mistake in my code because of DHCP. So I blame DHCP. It wasn't my fault. We exclude multiple BRs from publishing the OSNR prefix with DHCP. So, for the simple reason that we don't want to have multiple OSNR prefixes. And so this seems to be working. We ran into a really fun bug with a particular home router that it would you would ask it for a prefix delegation and it would give you the IP address that would give you the prefix that's configured on your home network.
Not just your home router.
Huh?
Mine too.
So the other one was also in Japan.
Yours also Huawei?
I think so.
Yeah.
Okay. All right. So yeah, that's fun times. So it's fun. We're learning all of these cool things. But one of the things that I really like about having done this work, I mean, it's something that I feel kind of chuffed about, is that like there are a lot of home networks that weren't really using IPv6 before that suddenly now are, and they don't even know it. And we've actually created a situation where if you don't provide DHCP-v6 PD, your users aren't going to be as happy as if you do, which wasn't the case before, right? So we've essentially created a new demand for home routers that actually correctly implement DHCP-v6 PD. I hope that actually results in more home routers doing it. We'll see. So next slide.
Is there some works with Thread logo or something that could be deployed to the CPE manufacturer's advantage?
Yeah, we're it's not Thread, but yeah. Are we allowed to talk about it? I don't know. I'm not the IPR expert here.
Yeah.
I can talk about what I'm doing.
Okay.
I have been talking with some other people in another organization, which is not Thread, which is CSA, which is the new name for Zigbee, which is doing the Matter protocol, which probably everybody has heard of. And one of the things some of us are pushing for is to make a certification program for what constitutes a good quality home network that will give a good user experience with Matter smart home IoT devices. That work is not so much about defining protocols that home gateways have to implement, although it could include that, but primarily it's a certification program that says these are the properties that we think lead to a good user experience, and if you meet this checklist, then you get to put the work, you know, the Matter certified home gateway logo. And we're hoping to use that as a vehicle to encourage home gateway makers to meet certain minimum standards, because right now there isn't anything in the industry. Like if you get a home gateway and you can reach Google and Amazon, right, the average customer's happy, it works as far as they're concerned. And things like Wi-Fi airtime fairness, there are a lot of things that we know about theoretically that improve the user experience, but nobody is collecting a laundry list of these are the things you have to do. So there are a group of us pushing to try to put a program like that in place for Matter.
By the way, I was not looking at my watch to make it go faster. I was just checking because, you know, but thanks for telling us about that.
So this could be for Stuart. I just checked. I have multiple Apple TVs at home, and one of them has acquired a ULA/64 from my home router. So they did some kind of election between them, and one of them decided, you know, go for it, and that's what's happened.
Yep.
Okay.
Yeah, or it depends on what models you have, because it's only, I think, the two most recent models that actually support Thread. So the ones before that wouldn't have gotten one, even if they're
right. So
yeah.
I have one of the more recent ones.
Okay. Yeah.
Or
It may be that it's
two, actually.
Oh, yeah. So if you've got two, then that's what's going on. It's one of them won the election, basically.
Just so we don't misinform anybody, it would be nice to say all recent Apple TVs do this. Unfortunately, it's not that simple.
Oh,
the old 4K model does do it. Of the two new models, the higher priced one does it. The one that's got Ethernet also has a Thread radio. The lower cost one, as well as losing the Ethernet, I believe, losing the Thread radio was one of the cost reductions. So if you care about this and you're buying a new Apple TV, make sure you get the Ethernet model.
You're grounded.
I actually noticed that, and I did get the more expensive.
Shameless sales pitch.
So I do have. So one of them is a 4K, and one of them is the higher spec.
All right, moving right along. A little free Apple advertising here. Yeah, totally. Lux. Yeah, buy two. Okay, so let's see. Yeah, so the last thing I wanted to say about this, I think this is the last slide. So
you should have 4 more.
Oh, 4 more. Yeah. All right, I'll go fast. Yeah, so we're currently, we talked about what kind of routes to advertise on the stub network for Thread. As Lorenzo suggested, we actually do not advertise specific routes. We just advertise a default route, or I think, correct me if I'm wrong about this, Jonathan, if there isn't a default route on the infrastructure network, then we advertise just FCOO, because basically so that you can reach any ULA, but nothing else. We explicitly don't support multiple adjacent infrastructure links right now. If you do that, good luck to you. Actually, I shouldn't say that. We support it, but only if they have working routing, only if they're connected to the same infrastructure. So next slide. Discoverability. So we provide if an AIL host wants to discover a Thread host, it can use MDNS to do that. And the way the MDNS information is populated is using SRP. So it's an advertising proxy. See the DNSSD working group for details. Works pretty well. We have noticed some issues. We wind up with many more devices than you would expect from, like, if you just had a printer and a couple of other things like your home stereo or something. Now we're talking tens or possibly hundreds of devices advertising. That produces more multicast traffic. So there are issues with that we've noticed. And we're hoping to move to unicast, but we're not there yet. And then if thread hosts want to do discovery, they can only use unicast because we don't support MDNS on thread. So, but we do have a router that, a resolver on every thread border router. So you just talk to the resolver, you ask it your DNSSD questions, and it gives you the answer, either looking in the SRP database or by doing MDNS if it's discovering something on the adjacent infrastructure link. Julius.
If you have time, could you say a few words about the issues with large MDNS?
With
your second point.
With the
what kind of
multicast?
issues you've noticed, if you have time.
Yeah, I talked about this at length in the DNSSD working group. It might be worth looking at those presentations because I actually, even if you just read the slides, there's a lot of information about this. But the basic deal is, first of all, you've got multiple border routers acting as advertising proxies, which means that any SRP registration is going to get advertised by each of them. We limit it to 5 with thread, but that's still a lot of multicast. And now let's say you've got 100 devices. Well, now you're multicasting information about all of those devices. When the registrations happen, all of that multicast happens at once. So an SRP server will synchronize with another SRP server and get its database, and it will advertise all of the devices in that database using MDNS, and that's just a lot of multicast traffic. So it just depends on how many devices you have, and we talked a lot about that in the DNSSD working group with regards to what we could do to mitigate those issues and reduce that traffic to as close to 0 as possible. So we've got some good ideas there, and I think.
So it's a pacing problem. Is it a pacing problem, or is it a pacing problem,
No,
or the total quantity is too large?
We're doing a lot of useless work, basically, that we could just eliminate entirely. Not really a pacing issue.
Okay,
I mean, there could be some pacing as well, but mostly it's just like, you know, you don't, if you've got 5 routers or 5 SRP servers cooperating to advertise the same information, they don't all need to do multicast probes retransmitted multiple times to verify that nobody else is using that address. Basically, we need one device to probe, and then once that probe is successful, we can assume that there isn't a conflicting record being advertised on MDNS because somebody probed it, and we don't need all of the other devices to also probe it. And that saves, if we don't do that, that saves a huge amount of traffic. Similarly, if somebody does a query, ideally we would like it that not all of the routers answer the query. Because of the way that Wi-Fi works, the query might be delayed by a fair amount of time, and the answers might be delayed by a fair amount of time. So we don't necessarily have an opportunity to see the answers. Like, normally what we expect is an MDNS answer will get sent, and all of the other things that could have answered will see it, and so they won't answer. But with the way that Wi-Fi, like, you know, there are these 100 millisecond or multi-100 millisecond gaps where multicast traffic isn't seen, you might wind up with 3 different devices sending the same answer because they didn't see the other answers because they all sent them before that gap ended. So
that's clear. Thank you.
That's the general problem. But I think this is kind of out of scope for here. I would really encourage you, if you're interested in this, to engage with the DNSSD working group, because we're actually planning on digging into this problem and solving it. We really want to solve this problem. And thank you for asking, because I think it's an important problem.
You have 2 minutes to wrap up
Okay.
everything.
All right. So let's see. Yeah, so we covered that. Next slide. Reachability for IPv4. So we provide NAT64. If the infrastructure does it, we use the infrastructure NAT64. If it doesn't, we have one thread border router do NAT64. We already talked about the DNS synthesis stuff. We don't currently implement Pref64, but we should. That's that. Next slide. Partitioning events. Yeah, we used to do something really fancy here. It was very clunky and it worked very badly. And now we do something really simple, which is what I described earlier. The main disadvantage of that is with thread, it takes a while for thread network data that's in the thread network data to fall out of the thread network data. So if we get a partition, it could be, I think, up to 240 seconds. I'm somewhat pulling that number out of my hat, but I think it's right, up to 240 seconds before we actually see that information go away. And we don't publish a new OSNR prefix until the old one goes away. So there can be a period where we have ambiguous routing in that situation. But So I think it would be good to do some more work on this, but that's where we are right now. Next slide. Okay. That's it. We have 0 seconds for questions.
No, that was a very good session. I mean, we had a lot of interaction both on the draft and this one, so I'm happy about it. Couple, I don't have time to pull up chair slides, but couple of things that I wanted to bring forward is that there is some amount of scope in this document, but we were planning to spawn other documents that will focus on other corner issues. So maybe we should bring it to the list. What are those documents, and ask for contributors if somebody wants to spin off or start something, and then you can advise them.
Yeah.
So that's something we should.
Yeah, if anybody wants to, if anybody has stuff problems they want to solve in this space, I would be happy to support that, particularly if they're doing it and not me.
All right. So from my perspective, we are done. Thank you very much, Ted, and safe travels, everyone. Thank you.
I have a really sore throat yesterday, and I'm back again. This stuff we were getting, like, yeah, it seems like kind of okay. Yeah, I got the stuff reader, like, oh yeah, but like, and now like, oh, I'm another stuff reader. Clearly, you and I speak the same language, so I'm just gonna stop talking because you can do everything I need you to do anyway. Yeah. And it's like because it was fun, but I mean that's kind of.
You skipped your lunch.
I did I was getting very hungry.
I hope
And I realized I had cookies there. I'm like, I'm eating those cookies.
It's like you skipped lunch and breakfast both. Thank you. Next time you will drive everything.
Okay.